A beverage can may look perfectly closed, yet one acceptable measurement can miss a localized seam defect. This video explains how the double seam is formed, what quality teams inspect, and why every limit must come from the exact can and end specification. The double seam is the mechanical closure joining the can body to its end. Its integrity matters during filling, conveying, transport and storage, when leakage or a damaged closure can compromise the package. Inside the seam, the folded body flange becomes the body hook, while the end curl becomes the cover hook. Their overlap creates the mechanical interlock, and sealing compound supports the closure without replacing correct metal formation. A can seamer presents the end, lifts and centers the can, and supports the assembly against the chock. Correct end placement, stable transfer, clean contact surfaces and matched tooling all influence the finished seam. The first operation roll folds the end curl under the body flange and establishes the hook relationship. The second operation roll compresses the correctly formed layers. Extra pressure cannot reliably create a missing hook. The chock, roll profiles, bearings, lifter and transfer system must remain aligned and repeatable. Wear, looseness, contamination or unstable lift can change the seam even when a recorded setting has not been intentionally altered. A seam plan may include thickness, width, countersink, body hook, cover hook, overlap, tightness and pressure ridge observations. No generic ideal value applies to every can size, end design, material, tooling system or measurement method. A seam can appear acceptable at one position and still contain a localized defect elsewhere around the circumference. Sampling should preserve position, head or station, component lot and production time traceability. No single inspection method provides a complete picture. A controlled program combines full circumference visual checks, external measurement, teardown or cross-section analysis, and any validated supplemental integrity test. The same visible symptom may result from component damage, incorrect placement, tooling mismatch, contamination, alignment error or wear. Measure the observed condition before assigning a root cause or changing the machine. When a seam is out of specification, first contain the affected interval and confirm the components, tooling and approved limits. Qualified personnel should diagnose the actual cause, change one authorized variable, make new traceable samples and verify before release. A capable seamer supports consistent centering, tooling motion, end feeding, transfer and traceability, but mixed components, delayed inspection, worn tooling or unrecorded adjustments can still create variation. Machine selection should begin with controlled can and end drawings, product conditions, required output, line interfaces and the inspection plan. Acceptance should use representative samples and agreed factory and site criteria, not headline speed alone. For the full engineering guide, visit n.zjweechi.com/why double seam quality is critical. The direct article link is in the video description.